Welcome to the graduation projects orientation for spring 2022 for my project that I'm offering for Mechatronics students. My name is Dr. Eman Azab, and I'm going to present to you in this short video an overview over the projects that I'm offering for your major for this semester. For spring 2022, I'm going to focus on two themes in my graduation projects. The first one is using artificial intelligence for Industry 4.0 application, and the second one is sensors applications. I'm offering 4 projects in this scope, 3 in the scope of AI for Industry 4.0 and 1 in the scope of sensors applications. So let's dig in and see these 4 projects, what are they focused on. In the theme of AI for Industry 4.0, I'm going to offer my first project is in the field of automation, which is going to be design of a camera tracking system for omnidirectional wheeled conveyor system. You know that we have an omnidirectional wheeled conveyor system fabricated in the GUC. And the focus here will be on how to employ embedded systems to actually design and implement a complete camera tracking system for the packages on the omnidirectional conveyor. At the beginning of the project, we're going to study the state-of-the-art on object tracking using computer vision. We will study the machine learning and image processing techniques for object tracking. The student from Mechatronics is going to be focused on the embedded system design and implementation of the object tracking system. I would like to draw your attention that this project is going to be offered as well to MET and IET students, but the MET and IET networking students will be focused on using doing the data engineering part for the computer vision, so they are not going to be involved in the embedded system design. The tools that we're going to use, of course, will be Python, C++, and MATLAB to code and program the hardware that we would use at the end. And by the end of the project, we would like to have a hardware prototype that it's actually tested and with the validated results. The project is co-supervised by Associate Professor Dr. Lamia Shehata and my colleague Dr. Maggie Mashali, and we have a master student, a research assistant that who is going to work with us, of course, in this project, which is Engineer Mohammed Ihab. So Engineer Mohammed Ihab will be responsible for the team, the Mechatronics project here, and the two projects offered to MET and IAT. In the same theme of AI for Industry 4.0, we will have 2 more projects, projects 2 and 3, which is design of machine health monitoring system 1 and 2. Here we're going to focus on condition-based monitoring and predictive maintenance hardware support system. So we're going to start by studying the state-of-the-art for condition-based monitoring hardware. For example, if you have a machine and you want to measure its vibration or its temperature, its how good the viscosity of its oil, we would develop a hardware platform to be used for maintenance. So we'll start by developing and implementing a PCB for condition-based monitoring and predictive maintenance data collection. We will do the data collection and pre-processing, and finally we will use this data to estimate the predictive maintenance times. The tools that we are going to use in this project will be Protus, Arduino, Microsoft Azure. Protus is going to be used for PCB design, of course, the same as Arduino, or you might be needing some microcontroller coding as well. And the Microsoft Azure is going to be used for the predictive maintenance time slots calculations. At the end of the project, I would like to have a hardware prototype that's actually up and running. And again, this project is co-supervised by Associate Professor Dr. Lamia Shehata and Dr. Maggie Mashali, and I am the main supervisor. The final project that I'm offering this semester is in the scope of sensors applications, and I'm going to focus on industrial applications. The fourth project is non-invasive current monitoring system using 3-axis magnetic field detection system. So the basic idea here is going to focus on using magnetic field sensors to estimate the position and magnitude of the current without intercepting the circuit that current flowing in. It's designated with 2 because I'm offering this project as well to electronics majors. So we have 1 and 2, so we would have 2 students ideally working on the project. At the beginning of the project, we will study the fundamentals of magnetic field sensors and their signal conditioning circuits, and then we'll move on to fabricate and measure a printed circuit board with the signal conditioning circuit of the magnetic field sensors. We already have a prototype for this PCB, so we would be able probably to do the measurements at the beginning of the project. At the third step, we will compare the theoretical equation that was derived to estimate the position and the magnitude of the current, okay, and compare the theoretical and measurement results for verification. The tools that's going to be needed for the project will be Protus or Altium for printed circuit board design, and we would use MATLAB for the theoretical part verification. And bear in mind that you will go to the lab to do the measurements, the physics lab to do these measurements. So at the beginning of the project, we expect to have testing and validation of a new hardware prototype. With this, I conclude the 4 projects that I'm actually offering to Mechatronics major, and I hope that you would be able to select a project that actually increase your knowledge and falls into the skills that you would like to learn. If you have any questions, please don't hesitate to send me an email, and good luck and have a nice mid-year recess vacation. Bye bye.